Hello and welcome. My name is Alexander Moreira, and today we're going to be discussing the problem more cow photos. In this problem, we are given a collection of n numbers, and our goal is to find the maximum length of a sequence such that the sequence is symmetric, the sequence has no number next to a copy of itself, and the sequence is strictly increasing towards the center. So let's take a look at some example sequences. So all of these are valid sequences based on the definition above. We can see here in this largest example, the sequence is increasing. It reaches its maximum point at the center and then starts decreasing. So that satisfies the third part of the definition. No number is next to a copy of itself, so that satisfies the second part of the definition. And if I were to reverse the sequence, I'd get the exact same sequence back out. So this satisfies all of those definitions. So now let's take a look at an example input here. So I'm given 7 numbers, and I want to produce the largest sequence possible using a subset of these 7 numbers. Note that the order doesn't matter. I can rearrange the numbers however I want. And it turns out that the longest possible sequence I can create is a sequence of length 5. We can see that 2 appears twice, so I can use 2 on the start and end. Then I have 2 copies of 3, so I can go 3, 3. And then I can use 1 copy of the largest number to cap off the middle here. And this would mean my output is 5 because the length of this sequence is 5. And this leads us to a pretty important observation. Note that we couldn't use 1 in this sequence because it doesn't appear twice, right? So I can't add a 1 to the beginning because there wouldn't be another 1 to add on to the end to match it. So the only number that can appear once in the sequence is this special middle element, which just corresponds to sort of the maximum number. So the maximum number can appear once, but every other element of my sequence has to appear twice. And this is our critical observation. We just need to know how many numbers in the sequence appear at least twice in the input. So to do that, we can use a frequency array. So our first step is we're going to use a frequency array to count the frequency of each number, and then we can count how many numbers appear at least twice. For each of those numbers that appear at least twice, we'll be able to add 2 elements to our sequence. Then the second part here is casework, and it's casework depending on the largest element. So for example here, this is an example frequency array. These are the corresponding indices. So how you'd read this data is this is saying we have 0 copies of 0, 2 copies of 1, 4 copies of 2, 1 copy of 3, and so on. And what you can see here is since I have 2 copies of 1, I can add 2 1s to my sequence. Since I have 2 copies, or at least 2 copies of 2, I can add 2 2s. I can't add any 3s because I don't have at least 2 copies. And then I can add at least 2 copies of 4, or since there's at least 2 copies of 4, I can add 2 copies of 4. And then the maximum element, because it's the maximum element and it goes in the middle, I can get away with just 1 copy of the maximum element. So I get 2 1s, 2 2s, 2 4s, and 1 5 to give me the sequence 2 1 2 4 5 4 2 1. So this would be one case. The second case is when the maximum element appears more than once. So here I've lost my copy of 5, so now the maximum element is 4, and I can only create the sequence 1 2 4 2 1. So if the maximum element appears multiple times, I can't use it multiple times in my sequence because I'd end up with 2 numbers right in a row. So I have to do a little bit of casework here. If the maximum element appears exactly once, I can take my count and add 1 to it. If the maximum element appears more than once, then I have to take my count of the number of numbers that appear at least twice and subtract 1 from it. To start off here, let's begin by reading in the t separate test cases, and then we're going to declare a function called solve, which is going to solve each of these independently, and then we're just going to print out whatever solve returns. So we can think of this as sort of one test case for the problem. We're going to read in the number of numbers we receive, and then we're going to read in the heights, which are the values between 1 and n. So I'm going to subtract 1 from them so that they become values between 0 and n minus 1. And then I'm going to create a frequency array storing n slots, one for each possible value of the heights. And I'm just going to loop over for each element in the height array. I'm going to increase the frequency at that index by 1. And what will happen at the end of this loop is frequency will store the frequency of each height in the original array h. And then my objective here is to simply loop over this frequency array and count how many elements appear at least twice. For each element that appears twice, the number of elements in my sequence will increase by 2. So I'm going to start a count at 0, loop over the frequency array one more time. If frequency is greater than 1, I'm going to increase the count by 2, and then I have to decide what to print out. And again, we have this little bit of casework here. If the maximum element occurs exactly once, we print out count plus 1. That corresponds to this case, where we were able to insert this value of 5 between the two 4s. Otherwise, we have to return count minus 1. That corresponds to this case where we weren't allowed to have two 4s in a row, so we had to delete one copy of the 4. And that completes the program. So thanks you guys so much for watching, and I'll see you guys in the next one. Bye-bye.